Hello everyone, today we're going to be doing question 3 for the ratio test for convergence review worksheet. If you have any questions about the ratio test specifically, there'll be another video that you can watch. So let's dive into question 3. Which of the following series converges? Circle one of the options. So we have three series that we're going to be looking at. This one here, and this one here. I'm going to start off by going through number one, and then we'll go down and do number two and number three. So the first series that we have is the summation of n equals 1 to infinity for n factorial divided by n to the 15th power. Now, when we're utilizing the ratio test, it's important to remember what we're doing and what we're looking for. We are essentially taking the limit as n goes to infinity for the absolute value of a sub n plus 1 divided by a sub n. So our first step is we want to see what a sub n is. A sub n is our original term that was given to us for the series. So a sub n is equal to n factorial divided by 15. And then our a sub n plus 1 is going to be it's going to look a little different because we're going to substitute n plus 1 into n. Thus, we have a sub n plus 1 is equal to n plus 1 factorial divided by n plus 1 to the 15th power. So what we're going to do here is we're going to take the limit of the absolute value of a sub n plus 1 divided by a sub n. First, we substitute in our values that we have. So we have our a sub n plus 1 and our a sub n that are being substituted into our formula right there. Our next step you might notice is a little different looking than what we were doing before, but that's okay. So first thing that you might notice is that instead of dividing, we are now multiplying, and that's because we have a fraction divided by another fraction, and when we have that, we take the bottom fraction and we take the reciprocal and multiply it to the other fraction. So that is that there. And then after that, our next step is to combine like terms, simplify, expand, whatever we need to do to make this look a little easier and understandable. So right here, you can see that I take my n plus 1 factorial and make it n plus 1 times n factorial. And I do that because n plus 1 factorial is equal to saying n plus 1 times n minus 1 dot 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 until we get to 1. N plus 1 times n factorial is saying n plus 1 times n factorial is equal to n plus 1 times n minus 1 dot 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 till we get to 1. So that is the same thing, just written differently. I also have here we can see that we are able to reduce because we have this n factorial in this denominator and n factorial in this numerator. So then we move on to our next step here, and we see that we have n to the 15th power times n plus 1. So essentially, if we kind of round, our our power here would be n to the 16th. That would be our highest power on the top. Our highest power on the bottom is n to the 15th. When the power on the top is higher than the power on the bottom, that means that our limit is approaching infinity much faster. Thus, our limit here will approach infinity. Therefore, infinity is greater than 1, and therefore the series diverges and does not converge by the ratio test. Our next series is this one here. We have the summation of n equals 1 to infinity, where it is 5 to the power of n divided by n factorial. Now, we are finding the same exact thing with the same exact steps. So our first thing is we want to define a sub n, which we do here, and we define a sub n plus 1. We then substitute those in to where we need to in our limits. We take we take the reciprocal and multiply that. And then we're able to start canceling out our terms. So we see that we have a 5 to the power n in this numerator. We have a 5 to the power of n in this denominator. We have an n factorial and we have an n factorial. Thus, we are left over with the limit as m approaches infinity for 5 divided by n plus 1. Our power on the top is 0 and our power on the bottom is 1 because our n has a power of 1 and our n has a power of 0 on the top. We know that the bottom is approaching infinity much faster, but the top part is staying constant, and thus it's approaching 0 because it's getting smaller and smaller and smaller. Thus, 0 is less than 1, and our whole thing converges by the ratio test. Our last one here is this series. We have the summation of n equals 1 to infinity, where pi to the power of negative 8n minus 9 divided by n factorial. Here is our a sub n. Here is our a sub n plus 1. We are now taking the limit as n goes to infinity. Here's our first step. Our second step where we take our reciprocal and multiply that. This is me simplifying and expanding terms. So right here, you can see that we have our negative 8 times n plus 1 minus 9. So here's our negative 8n, or negative 8n here. We have our negative 8, and then we have our negative 9, negative 9. And from here, we can simplify some things. So we see that there's a pi to the negative 8n power here and here. There is a pi to the negative 9 power. We can simplify that. And we have a n factorial, which we can then reduce there too, leaving us with the limit as n approaches infinity for pi to the negative 8th power divided by n plus 1. And because the bottom is approaching infinity much faster and the top is staying constant, our fraction is getting smaller and smaller and smaller. Thus, it is approaching 0, and 0 is less than 1. Therefore, it converges. So our two series that converge is series 2 and 3, and thus our correct answer is B.